Okay, so this is a short video on 3.2 linear functions, specifically function notation. Remember, function notation is a method for writing variables as a function of other variables. It's just a fancier way of saying y equals. So the first we're going to do is write the equations using function notation. So the first one says y equals 7x minus 1. All you have to do is f of x equals 7x minus 1. You can also change it and make it a function of g. So like this one, if I did the second one, y equals negative 3x minus 5, and I want to make it a function of g, I could do g of x equals negative 3x minus 5. And then y equals x plus 2. Let's just go back to the f of x equals x plus 2. Now this says evaluate each function for x equals 2 and x equals negative 6. So all I'm doing here is I'm plugging 2 in for x. So I have f of 2 equals 4 times 2x. Ooh, not 2x, just times 2 minus 3. 4 times 2 is 8. 8 minus 3 is 5. So f of 2 equals 5. We're going to do the same thing for negative 6. So f of negative 6 equals 4 times negative 6 minus 3. 4 times negative 6 is negative 24. Negative 24 minus 3 is negative 27. So I have f of negative 6 equals negative 27. So now we're going to do the same thing for f of x equals negative quantity x minus 2. So I'm going to have f of 2 equals negative 2 minus 2. Negative 2 minus 2 is 0. Negative 0 is just 0. So f of 2 equals 0. Then I'm going to do f of negative 6. So then I have negative 6 minus 2. Negative times quantity. Negative 6 minus 2 is negative 8. Remember, this is just an imaginary 1 right here. So it's a negative 1 times negative 8, which is just positive 8. So I'm going to have f of negative 6 equals 8. All right. So now we are going to write a linear function rule for the data in the table. So you're going to do just like the last unit where you have to write an equation from the table. However, in the very end, you're going to put it as a function, so f of x. So first thing I need to do is find 2 points so I can find my slope. There's 1, 1, and 3, negative 3. So remember, those are just points. Now remember, the slope formula is y2 minus y1 over x2 minus x1. So I'm going to label x1, y1, x2, y2. So I have negative 3 minus 1 over 3 minus 1. Negative 3 minus 1 is negative 4. 3 minus 1 is 2. Negative 4 divided by 2 is negative 2. That's my slope. Now, because I have my y-intercept in the table at 0, 3, I could just write my function using that. But we're going to pretend like we're not given that, and we're going to use something else so we can practice it. So I'm going to use the point 2, negative 1. So first I'm going to write y equals negative 2x plus b. I need to solve for b. So that means I'm going to plug 2 in for x and negative 1 in for y. So I have negative 1 equals negative 2 times 2 plus b. Negative 1 equals negative 2 times 2 is negative 4 plus b. Add 4 to both sides. 3 equals b. So when I rewrite this, I have f of x equals, my slope is negative 2x plus 3. All right, the next question says, Aubrey and Charlie are driving to a city that is 120 miles from their house. They have already traveled 20 miles and are driving a constant rate of 50 miles per hour. Write a function that models the distance they travel as a function of time. So that means your x is going to equal time. What is the reasonable domain for this situation? So first I have to come up with my function. This is my total, so that would be my y, if you will. My constant rate is 50, and they've already gone 20 miles. So I'm going to have f of x equals 50x plus 20. That would be my function. Now I need to find my domain, which is my x's. My x's is time. So I'm not given the time it takes, but I'm given how many total miles, which would be y. So I'm going to put in 120 equals 50x plus 20 and solve for x. So subtract 20 from both sides. I have 100 equals 50x. Divide by 50. 2 is going to equal x. So 2 is going to equal hours, or x is going to equal 2 hours. So my reasonable domain would be 0 less than or equal to x, which is less than or equal to 2. Because the longest it's going to take me is 2 hours. Now, if I'm going at a constant rate of 50 miles per hour. It doesn't ask for my range, but if I wanted to do my range, a reasonable range would be 0 miles, so 0 less than or equal to y, to 120 miles. All right, the last question. A staff gauge measures the height of a water level in a river compared to the average water level. At one gauge, the river is 1 foot below its average level of 10 feet. It begins to rise a constant of 1 feet per hour. Graph linear function to show the change in water level over time. So, the first thing I'm going to do is I am going to write my function. So I have f of x equals, my constant is rising 1.5x, so positive 1.5x, and it's starting at negative 1 below. Okay, so now I'm going to graph this. So my starting point, we're graphing this just like it was y equals 1.5x minus 1. So I'm going to start at negative 1. Another way of 1.5 would be 3 over 2. Okay, so I'm going to go up 3, 1, 2, 3 over 2. Up 3 over 2. If I go down 3, I have to go to the left 2. So there is my line. And so I graphed it. It says, will the level reach 7 foot above normal after 5 hours? Explain. So there's a couple different ways we can do this. X equals hours, okay? So then we're going to do, I could put in f of 7 equals 1.5 times 7 minus 1. And then solve this. So I would have 1.5 times 7 is okay. So we set this, I set this up wrong. I put times 7 because that's 7 feet. That's your range. I need to put in 5 hours because it's after 5 hours. So that is my fault. I apologize. Sometimes I make mistakes too. So then I do 1.5 times 5, which is 7.5 minus 1. So after 5 hours, it's going to be 6.5 feet. So no, it will not, because it's only 6.5 feet. So the answer is no. Okay, that is all. If you have questions, please make sure you ask, and I will see you in class.